All right, Algebra 2, here's your Unit 1 test review. All right, which statement represents the domain of all real numbers? So first of all, domain is x, and all real numbers means it goes from negative infinity to positive infinity, right? So remember, you got to put less than, and since we're talking about domain, there's an x in the middle there, so it would be letter D, all real numbers, forever left, forever right. So there's no zeros involved and there's no y because we're talking about domain. Okay, number 2, write the domain of the graph and the interval. So again, domain is x, and x is from left to right. All right, so the domain, the furthest left it goes is -3. And since it's shaded in, I'm going to put less than underlined. Domain is x. And it goes all the way to the right to 4. It's shaded in, so less than underlined 4. It is including those endpoints. Okay. Number 3, write the domain in inequality notation. Oh, let me back up here. This was interval notation. So when we do interval notation, since these are shaded in, we're going to use brackets, -3, comma, +4, bracket. If it includes it, if it's shaded in, then you have to make sure you use brackets. All right. And on the next one, when we talk about inequality notation, that's when we're going to use those less than signs. All right. So on this one, domain. So from left to right, again, domain is x. X is from left to right, right? All right. So domain farthest it goes left is -3. My less than sign is going to be underlined because it's shaded in. Domain is x. I put the less than again. And since this one is open, I'm not going to underline it. It's going to be at 1. Okay. All right. So you're going to have one like that, similar to this on the test. So these ones that I circle are going to be on the test. Okay. Another one that you're going to have one similar to this, similar. Okay. What's the domain of the graph and interval notation? Okay. So interval notation. So the domain, how far to the left does it go? 1 shaded in, so it's a bracket 1, comma. And the other side, when you have an arrowhead, that means it goes forever. Forever to the right means infinity, and you have to put a little parentheses. It does not touch infinity. Infinity is not a number. Okay. Write the domain in interval notation. Okay. So here we go. The domain, how far left does it go? Well, -3, but it's open. So that's parentheses -3 to -1, and it's shaded in, so that's a bracket. Now, we have another interval, so I'm going to put a U that unites it, or union with. 2, which is not shaded in, so it's a parentheses, over to 4, which is shaded in, that is a bracket. Okay, so there's our domain. Now this is right the range. So range is a y value from bottom to top. Okay, so my range on the bottom is going to be -2, not +2. I got to look on this y-axis, right? So -2, and it's shaded in, so I'll put a bracket. All the way up to 5, it's shaded in, so we'll put a bracket. Okay. Number 7, write the range of the graph in interval notation. So again, range is y from bottom to top. Now think about this. How far down does this go if it's got an arrowhead? Okay, well, it goes forever. So I'm going to put parentheses negative infinity. And it goes up forever with the arrowhead. So it's infinity again. All right, so remember, arrowheads go forever, so you have to use infinity. Number 8, the range. So how far down does it go? So again, range is y from bottom to top. Well, that's the farthest down it goes on the y-axis is 0. So it's an equality notation. I'm going to put 0, less than or equal, because it includes it, it's not open, y. And then less than, and this goes up forever again, so with that arrowhead. So make sure you put a positive infinity. Okay. All right, and then number 9, you're gonna have one like this on your test. Kind of. The main thing it's gonna ask you on your test is about this line. What is this line called? Go ahead and write this down. This is called an asymptote. Okay, and then what is this type of function right here? This is exponential. All right, so what's the range in inequality notation? So again, range is your y value from bottom to top. So my range, how far down does this go? Well, it goes down and down and down towards -1 without ever touching it because of that asymptote. So you can put a parentheses -1. And it goes up forever, that's positive infinity. So remember, do not use a bracket because it does not actually touch -1 on the y-axis. All right, range and interval notation. So again, range is y from bottom to top. So the range at the bottom is 2, including it. So bracket 2 up to 0. That's open. So put a parentheses. And then we're connecting that with union to u. 1 shaded in is a bracket. Up to 3 not shaded in is a parentheses. Okay. Given the graph, identify the function as linear, quadratic, or exponential. So this is a straight line. This is linear. Okay. You can use your book to help you with this. This, number 2, is quadratic. And we kind of set up here on number 9. This is exponential. Looks like this. All right. You're going to have one like number 13. What parent function does this come from? So when you see the word log, okay, you know that that's logarithmic. The logarithmic family, or a logarithm. Logarithm. All right. And you have that in your parent function book. Which parent function does this come from? Well, I see a little 2 right there. Squared means quadratic. All right. Which parent function does this come from? If it looks like a V hitting a point and then going bouncing back up, that is absolute value. That is in your notes book. Okay. Find a point that lies on the inverse function of the graph below. All right, let's take this point. Okay, what is this point? The x value is 0, the y value is -2, right? Okay, I want to find the inverse, a point on the inverse. So inverse is when you switch x and y. So I'm going to take this and I'm going to get -2, 0. Okay, all you got to do is switch x and y. For the point they give you, you get a point on the inverse graph. 17, which is the following statements about inverse functions are true. Inverse functions undo each other. That's true. Inverse swap x and y, that's true. Now, you may not have known this, but when inverse graphs reflect over y equals x, the diagonal line, that's true. Okay, so it's actually all the above. These are all things we went over on our notes. Okay, now which image represents an inverse graph? Now A, B, or C, which one actually can fold diagonally onto itself? So here's the problem. On letter A, with a random K here, but on A, these don't line up. Like this would not, this would fold out over here or something, right? So it can't be A. B, yeah, looks good. What about C though? C would actually fold down the vertical y-axis. When it comes to this diagonal line, that's a no. It's a no-go. Okay. Diagonally, not vertically, and not any other way. Okay. So you will have one like that on your test. Make sure you do that. All right, write the inverse. Okay, so I'm going to rewrite this with a y instead of f of x. Then I'm going to switch x and y. X equals 2y plus 5. I got to solve this thing, right? So let's get rid of that plus 5, minus 5, minus 5. X minus 5 is x minus 5. And then your last step is to get rid of this 2, divide by 2, divide all this by 2. We can write our final form, f inverse x equals x minus 5 over 2, like that. You're going to have one like that on your test, and one like number 20. Let's try number 22. We're going to turn f of x into y. And then switch x and y. All right, now let's solve this thing. I'll get rid of that loner. Minus 1, minus 1. X minus 1 is x minus 1. Now remember, to get rid of a square, don't mess with that minus 3 yet. First, get rid of that square by doing the square root both sides. So I got square root of x minus 1 equals y minus 3. Last step, to get rid of that minus 3, we add 3 to the end after the square root. These cancel out, and I'm left with my final f inverse x is square root of x minus 1, and then the plus 3 has to be after the square root sign. You do have one of those on your test, so make sure you know how to do that. You're going to have one like 21 as well, which the following best describes how to algebraically prove functions are inverse of each other. Okay, is that when f of g, and again, it's not fog, but it's like f a floating OG and g of f if they give you x. This is so important. Okay, so when you verify f of g of x and g of f of x equals x, you know you have inverse functions. All right. All right, here we go. Let f of x equals 4 of x, g of x equals x plus 2, which of the following is a composite f of g of x. So f of x equals 4x. I want to put g of x into f of x. So I'm going to put a space here instead of x. I'm going to put a space here instead of x. Okay, so that's step 1. Write the outside function, f. Second step, replace x with a big old space. Step 3, put g of x in that space. So g of x is going right here. And then x plus 2 is going to go here. Last step, we got to simplify. This 4 is going to distribute. So f of g of x equals 4 times x, 4x. And then 4 times 2 is 8. 4x plus 8. Hey, you will have one like that on your test, so make sure you know how to do that. 23. Let's do another composite. F of g of x. So I'm going to just go ahead and cut to the chase. F, and then instead of x, put a space. And then equals 2. Instead of x, I'm going to put a space. Plus 10. So again, these x's I turn into big spaces. That way I can put g of x there. So g of x goes here. And then x minus 3 goes here. So let's go ahead and distribute that to 2 times x, 2 times negative 3. So 2x minus 6, bring down plus 10, combine like terms. So f of g of x is 2x, and negative 6 plus 10 is 4. All right, another one, f of g of x. So again, let's write f of x, but instead of x's, we're going to put a big old space. And then we're plugging in g of x into the space. So g of x, and then x minus 5 over 2. Now, when we simplify this 2 times and then divided by 2 cancel out. I'm left with x minus 5 plus 5. And then minus 5 plus 5, those actually cancel out too. So f of g of x is just x. It's a composite function. Let's do another one. It says, prove f of x and g of x are inverses using function composition. Okay, so if we do f of g of x, it should give us x. I'm having issues with this file. Okay, here we go. It's crazy. All right, so plug in g of x. All right, when you simplify this, the 3's cancel out, and then the minus 4 and the plus 4 are going to cancel out. So I get f of g of x equals x. That's great. If I do the g of x one, I replace x with spaces, and I'm going to plug in f of x, and then 3x plus 4. So on the numerator, the top, the plus 4 and minus 4 would cancel out, and then on top and bottom, those 3's would cancel out. So g of f of x also equals x. That's it. So you've proved that they are inverses because they both give you x when you do the composition functions. Okay, last ones. You want to sketch a graph or be able to identify a graph of each of these? So I'm going to do a very rough sketch. So quadratic looks like this, like a U. Square root looks like a sideways parabola, but only on the top. Okay, absolute value looks like a V. That's not a, it's going to be hard to do this perfectly here. All right, so it's a V shape. Exponential, it never touches something, and then it goes up like that. And then a logarithm goes up like this. And a rational does something like this, where you've got two parts of it. Okay? So, those are sketches of what you have in your parent function book. So you want to use this, study this, and be ready for your test tomorrow. Your test will be shorter than this, and if you focus on the stuff that I circled here, you should be all right. All right.